says that the interview report is going to be due next week. So pretty much what that is, it is a transcript of the whole interview. And besides the fact that we're doing it so we give you a hard time, it is so that you actually get a document that you can reference back. So you can actually say, well, in this line, in this document, it says that the client wanted this. Because otherwise it will be very difficult to go back and say, oh, well, in my video, in minute 27, second 15, the client wanted this. It's just easier to reference a written document than to reference a video. Okay? So anything? All right, well, if there are no more comments or questions or any complaints or anything, so let me go ahead and introduce Dr. Ralph Martinez. He is currently the director of the Regional Cyber and Energy Security Center, which is, as you probably know, that's where I actually moved. So instead of being in computer science full time, now I'm most of the time over there and just like 10% here. So, Dr. Martinez will actually give you a quick introduction of what we do on the center and some of the projects that we have on mind. Okay, and with that, let's welcome Dr. Martinez. The whole hour. So
1 hour or an hour and a half?
And like an hour, 20 minutes. So why don't we just start with a quick introduction of what the center does, and what you do, and all that.
I'm going to do a little bit more than that, but I'll tell you about what the center does. Okay, so you guys are all software engineering students, right? Everybody's computer science?
Yes.
Anybody non-computer science? Okay, so just as an introduction to what I've done with software engineering, I'm going to write some names of some systems down on the board that I worked on. Okay. Excuse me, I have a bad allergy this week. I'm just going to write them kind of in chronological order. This is for electric utilities. And this was done in assembly language. This is when higher languages weren't cool. And all we had was Fortran. There was also a system that I did for El Paso Electric that had to do with operations center, control and management. So as a visualization of everything that was going on in El Paso Electric territory when displays and large, CRTs and HDTVs and that technology was not available. This was a big wall board that had a map of the electrical system in El Paso Electric. And it was all controlled by a mini computer. So we did work in assembly language on that mini computer. Who knows what a mini computer is? Anybody ever seen a mini computer? Ah, you guys are great. I'm going to have fun with you, man. So before there was computers, there was big mainframe computers, right? IBM, big mainframes. In the late 60s and late 70s, companies such as Digital Equipment, who's ever heard of Digital Equipment Corporation? DEC. Data General started building mini computers. The big mainframe computers were anywhere from 36 bits, IBM, to 72 bits, word links. Control Data Corporation had the 72-bit word link computers. This was a mini computer application where the assembly language is based on a 16-bit word. The economic dispatch and flow control was also not only assembly, but it was in Fortran. And this ran on a 32-bit computer. also on a 16-bit computer. So I actually got introduced to assembly language before, like I said, the higher languages came about. Also did some work after I got my PhD at Arizona. I did some work for the Navy in which we did programs for the cruise missile. Everybody knows what a cruise missile is, right?
What would you like to ride?
Cruise missile is one of the biggest, one of the deadliest weapons that the United States has and the Allied forces have in their repertoire of weapons. This was the first weapon system that I worked on. And once I found out how lethal it was, I decided in my career that I wasn't going to work on weapon systems anymore. Because this thing can be launched from 2,000 miles away, and it can hit a window inside a city, 3-by-3 foot window, aimed from 3,000 miles away. So it's pretty lethal. So we did software for this in assembly, Fortran, and a language called Pascal. If you Google these two, you'll see that they were in the 70s and 80s kind of languages. And in the early 80s, I was lucky enough to be working at General Dynamics in San Diego, and we were working on the first GPS system. Everybody knows GPS, right? There's a GPS unit in here. And this was a classified program for the Air Force. I couldn't tell my family what I was working on. It was a really cool program because everything was hardware. This was Fortran. This was assembly language. And at the time when I joined the program, General Dynamics had 7 satellites, 3 master control stations around the world controlling the satellites. And we were building man-pack receivers, which are these guys these days, for the military, for soldiers. They were called man-packs that struggled in the back. And the man-pack was this big, and it weighed 25 pounds. The airborne version went into the F-16s, weighed 20 or 50 pounds. When we were working on GPS, and I was the system engineer in charge of the master control station for GPS. We were doing all this programming and monitoring the system that was running with 7 satellites. Eventually the system has 24 satellites, 1 master control station, 2 ground stations, and 8 monitor stations around the equator of Europe. So this was a big project. These projects, there was no software engineering guidelines here. We basically did it by the seat of our pants. In GPS, the government started putting software requirements on our teams, and it was called the MIL Standard 499, which is now obsolete. But these included hardware, software, and interface specifications, which are equivalent now to software requirement specifications and other documents that you guys generate. So we had to do these documents that were both for software, hardware, and interface control documents for this whole system. And you know the story about GPS. It got out of the Air Force, out of the government, they commercialized it, and now everybody uses it, and everyday life. Okay, also worked on some medical applications that were called Global Picture Archiving and Communication Systems. These allowed physicians around the world to communicate with each other to do a diagnosis on a patient. If you were at a hospital and didn't have a specialty on, let's say, neurosurgery or obstetrician or a pediatrician, then you would connect over the internet to exchange these images and do a remote consultation by looking at the images, voice, video, and information transfer between the two physicians. And this was called Remote Consultation and Diagnosis Systems, RCDs. They're very popular now by large manufacturers of medical equipment like General Electric, Toshiba Medical Systems, and so forth. So this was a large distributed computing environment system, because you had nodes in hospitals, physician workstations all over the world. And we actually did this initially for Toshiba in Japan. And then we did it for the U.S. Army. And then we did it for the Navy. So these were large programming projects. About this time, software engineering was becoming a real fad. It was really, really cool to have software engineering guidelines. And in fact, in remote consultation diagnosis, we used a system called Corba. Corba was big in the 1990s to 2003. And it was, it stands for Common Object Request Broker Architecture. If you Google it, it gives you the history of Corba. In the, if you go to the Object Management Group, the OMG, not oh my God, but it's Object Management Group. It tells you all about Corba. So Corba was really cool because it was object-oriented design. Big jump from software specifications under 499 mil standards. Big jump to object-oriented design. It was very popular in the 90s. This was overcome later by, right over here, web services. So the web started becoming very popular, and so everything with HTTP programming and so forth, and all the .NETs and all the stuff that we do now was based originally on some of the corporate principles. Okay. And then from here, there were several other systems that I worked on. Some of these may not mean much. JTRS is a Joint Tactical Radio System for the military, both the Army, Navy, and Air Force. And what we did, these were radio networks. This was in the early 2000s. And what we used in order to design these radio networks was a language called the Unified Modeling Language, UML. Who's heard of UML? Okay, so you've seen some of the structures. UML was actually developed out of the software engineering community. So people that worked on Corba, Jacobson, and these guys that did this work actually transferred into UML and has been very popular in the 2000s. It also led to another language, which is an offshoot, which is called SysML, or Systems Modeling Language. This is more for system engineers, and this is more for